welcome to Easy Calculus. In this video I'm going to be covering integration by parts. For the first 5 minutes I'm just going to go through the theory and where it comes from, and then I'll get into examples. There will be 10 examples for you to try. You can try them on your own, or you can try them, work them along with me as I work them out. So you can try these examples on your own, or you can just work them out with me and then try them on your own after the video. Okay, so let's start. So integration by parts, the formula for that is this. The integral of u dv is equals to u times v minus the integral of v du. And the place where that comes from is from the actual product rule. So let me write out the product rule and I'll show you how you get from the product rule all the way up to this. So the product rule says if you have two functions being multiplied, f of x times g of x, and you like to take the derivative of them, you just do the derivative of the first times the second plus the first times the derivative of the second. You might be writing it the other way around. There are different ways the professors explain it. And you end up with this. So now let's say I wanted to integrate this to go backwards where I came from. So what I'm going to do is I'm going to put integral signs and I'm going to rewrite everything on each side of the equation. I'm going to have this and I have to put dx, and then over here I'm just going to put this exact same thing inside of my integral. Okay. Alright, so now with the left side, if we take the integral of this, since it's a derivative, basically they just cancel out. The integral cancels out with the derivative. We're just going to be left with this. Alright, now over here, I'm going to use my integral, one of my integral rules where it says that I can separate addition into two separate integrals, so I'm going to do that. I'm going to separate this one and this one. Integral of f prime of x Alright, so now we're almost there. Now the next thing we're going to have to do is to, let me see. Okay, right. Now we're just going to subtract this from both sides. So because it's an equation, you can subtract. It looks kind of funny to subtract the integral, but you're perfectly allowed to do it. So I'm going to subtract this integral from both sides. Okay, so it goes away on the right side. And I'm left with f of x, g of x, dx. No dx. Dx should have went away. So f of x dx minus the integral of f prime of x, g of x dx is going to be equal to this. F of x, all this inside the integral, times g prime of x dx. Now the last thing I'm going to do is to just switch the order. I want this on my left side, I want this on the right side. And it's an equation sign, so I can just easily just flip them, there's no problem. So I'm going to put this on the left side, just rewriting it really. So now, we're almost home. So now instead of using f of x and g of x, I'm going to make a substitution. I'm going to call f of x to be u, and g of x is going to be v. So f of x equals to u, that means f prime of x equals du, g of x equals to v, and then I'm going to call g prime of x dv, based on the derivative. So now let's see what we have. So now we no longer have this, we have these letters are going to be used. So the integral, I'm going to put it over here, integral of f of x, which is u, times g prime of x, which is dv, equals and f of x times g of x, that's just u times v, minus the integral of f prime of x is just going to be du, g of x is just going to be v, so that's just going to be v du. And voila, you have integration by parts. So this is how you would go through the proof of showing how the product rule leads to integration by parts formula. Alright, so let's get started. Okay, so these are the 10 videos I'll be doing in this video. So I encourage you to work on them on your own, either before I do them or after you see me do them. That way you'll be able to just work through it by yourself to see how to get the answer. And if you get stuck, you can always watch the video. Alright, so let's start. Alright, so this is number 1. Integral from 0 to the power over 2 of x cosine x dx. And it's a good habit to write down your integration by parts formula before you do anything. That way, you can always glance back at it. Even if you remember it, it's good to have it on the page. So the next step is to pick your u and to pick your dv. Now, when you pick your u, there's a science toward it, and there's even an acronym that I'll show you at the end of the video that helps you with picking it. But for now, I'm just going to explain to you. When you pick your u, you're always going to end up with some type of integral after you use this formula. This integral should be the same difficulty as this one, or easier. If this integral becomes harder than what you started with, then you sort of picked the wrong thing. So the correct choice for you would be x, but I'm going to pick the wrong choice just to show you what I mean by the increased difficulty. So u is going to be cosine of x, dv is going to be x dx, and these are the wrong choices. So now the derivative of cosine x is going to be negative sine of x dx, and the integral of x dx is going to be x squared over 2. Okay. So now our formula says this, which is this part, is equal to u times v. So we're going to get, I'm going to just write this in the front, I'm going to write v times u. It'll be easier to see. Times cosine of x minus the integral of v du. V du is going to be this one, x squared over 2. So I'm going to put the 1/2 to the front and put x squared. It's supposed to be v du. Now du is going to be negative sine of x dx. So the negative sign I'm going to pull to the front, so just make a negative, which is positive. Then I'll have sine of x dx. Alright, so this is my new integral. So we're saying this is equal to this. Let's compare the integral portion of our two problems. So what we started with is this. Now, cosine and sine, integrating them, it's about the same difficulty because they're very similar functions. So with the cosine and sine, that's pretty much even. But comparing x and x squared is hard to integrate because this is x to a higher power than this one. So in effect, our problem got worse. And we'd have to do another integration by parts. And if we pick the same method for picking our u, then it'll be x cubed, so it's going to keep getting worse, getting worse, getting worse. So we know we picked the wrong thing because this is worse than what we started with. So that's a good hint to know if you, hey, I made a mistake. Alright, so now let me go through the problem where I actually picked the right thing, and I'm going to go through solving it. So the correct choice is actually x, and du is dx. dv would be the cosine of x dx. And then the v would be the integral of cosine, and that's sine. So sine of x. Alright, so now this is equal to u times v. So it's going to be x sine of x minus the integral of v du. V is sine of x, du is dx. So sine of x dx. Okay, so now let's compare these integrals again. This one, they both have sine or cosine, so that's the same difficulty in regards to the sine and cosine part. But this one has an x, so the first part, this one doesn't have any x at all. So this is an either integral. So that's an indication that we picked the right choice for u. And in fact we did. U is supposed to be chosen to be our x. So now, because this is a definite integral, we have to put our limits of integration. So it's from 0 to 2 pi, I need to put it here. Sorry, 0 to pi over 2, I need to put it here. And also here, 0 to pi over 2. Now I'm going to rewrite this part and then evaluate that integral. Now to evaluate this integral, the integral of sine of x dx, what did I differentiate to get sine of x? I differentiated negative cosine. So it's going to be negative cosine of x, evaluated from 0 to pi over 2. And now this negative is going to give me a big plus. And now what I'm going to do now is just rewrite it so I only have one limit of integration. So it's x sine of x plus cosine of x evaluated from 0 to pi over 2, and that's equal to, now I have to plug in the top endpoint, top limit of integration, minus the same thing evaluated at the bottom limit. So it's going to be pi over 2 times sine of pi over 2 plus cosine of pi over 2. Now it's a good practice to just put a subtraction sign and then just put a big bracket for the second, for when you plug in the bottom limit of integration. So it's going to be 0 times sine of 0 plus cosine of 0. Okay? I'm going to do that up here. Now, pi over 2 times sine pi over 2. Sine of pi over 2 is 1. So this is sine of 90, so it's going to be pi over 2 times 1. So it's pi over 2. I'm going to leave off the 1. Plus, now cosine of 0, cosine of pi over 2 is 0. So this is going to be plus 0. Minus, now this one, this is just 0, because you've got 0 times something, so that's 0. Now cosine of 0 is 1. So you're going to have minus 1. So this is, I'm just going to distribute this now, so it's just minus 1. So my final answer is pi over 2 minus 1. So for this one, all we did was we picked our u to be our x, and then we picked our dv to be cosine x dx. Then we found what v was by integrating this, and we found what du would be by taking the derivative of u. So in general, whenever you have a formula like this, anytime you have a question that looks like this, x to the n cosine of like ax dx, or x to the n sine ax dx, where a is a number and n is a number. Anytime you have an integral that looks like this, you want to pick your u to be x. And that's just a general rule. So it's going to work out better that way. Okay, so now as you do this problem, just remember to keep your limits of integration. Whatever they are, you need to plug them in when you evaluate this uv part. If it's from a to b, you need to put a to b here, and then from a to b to here, if you have a definite integral. Now if it's indefinite, you just put plus c at the end. And I'm going to have plenty of examples where you have definite and indefinite integrals. Okay, so now before I go on to number 2, I'm going to show you the acronym that helps you with picking your u's. And it's very useful because it can save you a lot of trouble. It'll solve a lot of your problems for you. I mean, it won't fix your card troubles if you're having card troubles, but it will fix your integration by parts problems. Alright, so here's the acronym. It's called V8. So this stands for logs. This is for inverse trig. This is for algebra. This is trig.